So here we are with the Ocean Acidification Lab follow-up 24 hours later, which I didn't plan on actually doing this 24 hours later. I was like, I'm just going to, cheat a few hours, but looking at my thing, it's 11 p.m. It's definitely 24 hours later. Okay, so the beginning here, we took 2 shells the exact same size. They're little mollusk shells, and they were the exact same size, almost even the exact same color, little blue rims in them, kind of. And I put one in 300 milliliters of water, and I put one in 200 milliliters of vinegar. Now, the amount doesn't matter, just as long as it was like completely covered. But as you can see, I'm going to come up to the camera here, and please excuse the mess. I'm packing to go away for some training, and I'm also, an all over the face kind of a person. Okay, so here is our shell in water. Looks pretty good. Look from the top view there. Looks pretty good, yeah. I'm going to shut that down. All right, here is our shell in vinegar. Look at the side. You can actually still see, if you look very closely, I don't know if the camera can capture it, but you can still see bubbles going up from the shell. So that means that it had started right away, where it was like bubbling around the shell, and it was basically breaking the shell down right away. And it looks like it is still doing that right now, because I can still see particles of this shell floating to the surface. And if you look from the top, you can see there is a nice little hole even in that shell, and the outside of the shell is not what it used to be. There's no rivets anymore. Everything's very smooth. There's no color. I'm going to pull these shells out so we can look at them. And these shells were the same size with the same coloring. So I'm going to pull these shells out so we can take a peek. Oh my gosh. Oh wow. Okay. Results even more in person here. So the biggest thing I noticed as of touch is that the shell in vinegar was so much more fragile. I felt like I was about to crush it in my hands. So this shell is nice. It's got a good little thick. It's still thick. It's still there. It's still, I could toss it around and nothing would happen to it. Still has all of its ridges, its colors. This shell, however, when I pulled it out of the water, I felt like I was going to crack it in half. It was very, very, very thin. It's very fragile. This whole side is actually sharp, because it's been wearing away. There's holes in it. It's very smooth to the touch. So, here are the 2 shells again. And they were the same size upon putting, oh look, even my fingers have turned white from this shell. Look at that. It's still breaking. It's just, it was continually breaking down. You can even see the vinegar is not clear. It's very, almost a foggy white versus the water. So you can tell those are all the shell particles that are in there. So in general here, what we're going to say, yeah, it's just, it keeps breaking apart in my hands even. This shell is like done. Even the bottom side. Look at that. Crazy. Crazy. In one day, this is what happened to a shell that was the same size as this shell. Just completely broke down. So what I can say is that wow, I didn't know it worked that fast. But what I can say about ocean acidification is that it is really bad, and we need to do better as human beings to protect our oceans, because we rely on them to survive. This message is brought to you by Bree from her at-home experiments.